Okay. Alright. I haven't streamed in like 2 years, but let's see if this helps the focus. Alright. The goal. The goal is to fix the P2D angular velocities. So right now I think I just have them disabled. And I think even that was causing some weird issues. See, like that probably should have hit into here. So there's a bunch of weird stuff going on. And it is not the same as the basic resolution, which does not account for inertia, which makes me think that something in the inertia calculations is very wrong. So I'm gonna have to figure that out. Okay. I was following along on this guy, 2-bit coding. He has a 2D physics engine series in C#. It's super helpful, but I think he does something weird as far as position is concerned. Because I'm not sure that he's using pixels for the in-simulation units, like I'm doing. Which means that these same values that work for him don't work for me. And there's no way for me to verify that because he open sourced the physics engine, but it doesn't include his test program that runs with it. So I have no way of knowing stuff like that, which is kind of annoying and confusing. But it doesn't really matter that much, because I can figure it out. So I spent like 4 hours yesterday double checking the equations in the Chris Hecker magazine article that 2-bit derives these from, and they look fine to me. So I think the biggest problem I had was in the Angular solver, the right side of the denominator was exploding. And I think it's mostly because of these inverse inertias. So he got those from this Wikipedia, Moments of Inertia. So this is one that he got, solid disk of radius r. Excuse me. The moment of inertia is 1/2 mass times radius squared, which gives us potentially bad values. So I'll play around with that a little bit and see what happens. So when we create an object, initially the mass and inertia is 0, which maybe stands out to me right now because we don't want to work with that directly, and I don't think we do. We work with the inverses. This is actually potentially wrong. In the case that A is static, this would divide by 0. So I wonder if this should be like J times object A inverse, I can't type, inverse mass. I doubt that would change anything. I think I'm still on basic, go back to rotational. Well, that actually seems to be a little bit better. I'm not totally sure in what regard, because these circles with inertia seem to want to just keep going, which might just be like a constant thing. Like, nothing is really wanting to push anything else to the side. It's kind of like pushing it with it. Or nothing wants to be stopped by anything. So if this is dropping, it kind of just crams it in, and then they get way too much velocity that should be dispelled by the stuff under it, and then basically it's not resolving. So that's something to think about, I guess. Check for mass, and then we can also check for using the inertia directly, which it doesn't look like we are. So let's just see. I tried to do calculations based on density, which I don't know. It's maybe not the best idea. That's how 2-bit does it, but maybe we can scale the values to be inside better ranges if we specify the mass in inertia ourselves. So let's just see what the mass and inertia values are when we drop in a circle. So circle has a really crazy high mass and a really crazy high inertia, which is probably part of our issue. Yeah, it's like 1, 2, 3, so like 17 million, whatever the inertia constant is. Like, so one thing to do is to try and just scale. So we could do like times equals, if the mass is blown to 5 places, we could maybe do like 0.0003 or 001, and bring it down to like 2. And then we could probably do the same with inertia, or we should probably do this mass thing before we calculate the inertia. Just let it propagate. So let's see. This becomes a mass of 7.85 and inertia of 10,000. And this is a mass of 10 with inertia of 17,000. So it seems like it's still proportionate. I wonder now. Okay, that's interesting. The rotation is applying. So I wonder if our problem is normalizing these values. Another thing is the rotational impulses are really low. We should be getting a lot of rotational impulses right here when it's on its side like this, but it's still actually rotating in the direction it was when it fell. So here it's not falling off. Here it's not falling off. Well, it's falling a little. It'll probably fall eventually, but it'll more like, yeah, it won't rotate all the way off. Maybe because it's super heavy. Let's scale down inertia a little bit and see what happens. The inertia, we can bring it down. Maybe also another factor of however much that is. Let's see. This brings the inertia more to like a 0 to 1 range. Actually a little higher, but basically single digit. It looks a little different already. Okay. I don't like the way it just shoved that there. But actually I'm liking a lot how it just pushed into the box and rotated it the other way. The box is getting a lot of acceleration there that it probably should not have. So what about we drop and build up a lot of velocity, and then... Okay. That almost doesn't look very wrong. But I think part of our problem is these resting contacts are very screwed up. So what happens with... So maybe this is correct. I guess it depends on what you would expect to happen when two objects collide in flight like that. So in the basic resolution, if we drop like that and interrupt it, it kind of bounces back up a little bit more. Yeah, it loses a lot of its momentum versus the rotational. It kind of seems to like add on. Yeah, so it basically doesn't get repelled off, which I don't think is proper. And the angular impulse is still looks really low to me. And I also bet if I were to drop a box, it would potentially not bounce. Yeah, okay. So it doesn't bounce on the double contacts. I misclicked. Let's see. So contact velocity magnitude like 400. So the denominator is still 1500, which is super high. I think we're more looking for like, I think we want the denominator to be less than 1. I meant to do a circle. Let's look at this. Yeah, so yeah, because it's making the impulse basically 0. I think our problem is the 2 points of contact. But let's see. So inverse inertia is 1 versus the rectangle, its inverse inertia is 0.6, which seems... I think maybe I need to build some intuition about inertia. Specifically relationship to mass. Objects stay in motion. Yes, that makes sense. But as far as how the inertia is derived, moment of inertia, mass moment, angular rotational mass. Angular momentum remains unchanged. Conservation of angular momentum. So maybe it says up here. The rotational analog to mass. Moments of inertia of a mass have units of dimension ml, mass length. So it's directly correlates to the mass. Second moment of inertia. Mass moment of inertia is known as rotational inertia, angular mass. Let's see. Body's moment of inertia about a particular axis depends on both the mass and its distribution relative to the axis, increasing with mass and distance. Okay. So the weight and... Okay. The inertia increases with the mass and the distance from the axis. So that means for stuff like this, it should maybe be a lot higher. But I think we were treating it as constants. Let's maybe see if the Hecker articles say anything. Okay. This looks really good, actually. I'm gonna take this sweatshirt off, actually. It's kind of hot. One sec. Okay. I also turned the fan on. Okay. So maybe take it from the top and see what Hecker writes and how he refers to the inertia. Turn the music down a little. Wow, no mentions of inertia. Generalized coordinates. Let's... I actually don't think this is what I'm looking for. Not the collision response one. Here it is. On rigid body dynamics. He linked Adobe Acrobat. He has sample applications for the articles. What is in the 2D? Didn't extract or what? Oh. No, it's already there. What the hell? Extract 2. Downloads. Okay. Maybe let's look at this. No targets. No make file found. Oops, I just deleted it. I meant to move it into Can I have my make file back? I don't understand what's happening. Okay. Missing separator. Let's just take a look at the code. Okay. From 96. It's really only a width and a height. I don't know if that's logical or absolute. Oh, he included the executable in here. Maybe I can run it with wine. Indeed. What is happening in this? Toggle gravity. World spring. It's just going very fast. I think it might be tied to frame rate or something. Okay. Well, it works. Cool. Where's the entry? Is it in Win32? Wow. Oh my god. App exit, app idle, win main. Okay. So where does he... app init. Create window, show window. Oh yeah, I just have both open. Cannot side by side in Kate? I guess not. So when does he call initialize body? Oh, he does it here. Okay. I mean, it seems like these are pixel coordinates. Run. World render. Okay. Clearly the delta time is not working. I don't know. I don't know if I'll get anything useful out of this. Maybe the integration. Angular velocity. No. Torque. Resolve. So he has, it seems like kind of the same thing. Well, it is the same thing. Over 1 moment of inertia. 1 over CMM moment of inertia. What is this? That is really small. YouTube is telling me to change the bitrate. Let's see. That should work. Okay. Over 1 moment of inertia, or 1 over moment of inertia. Where are we implementing that? Not in this file. Is there a body file? Oh. Over CM moment of inertia, some contact magnitude. What is R? Mass over R12. I don't know what R is in this. Is that real? Is that like float? I have no idea. Okay, I don't think this is gonna be very helpful. Let's just look at these. Does he talk about inertia? No. So this is the first physics. Also does not talk about inertia here. Does talk about mass. Maybe he only does forces. Center mass is CM. Yeah, I wonder if he talks about inertia as like moment of mass. Yeah, I'm not seeing anything interesting. Angular effects. Rotation, velocity, acceleration. Angular momentum. So mentions inertia. Since impulse will change the angular momentum, the moment of inertia at the center of mass. So that's what 2-bit talks about in not this video. In this one. Nope.
It's going to take care of
this one.
All right, well, certain direction. We're talking about an axis that goes through the center of our. It gives you a general idea of what the moment of inertia is. And it says, measures the extent to which an object resists rotational acceleration about a particular axis. And that's what we want. We want to know how much does this body resist rotational acceleration on a certain axis. Now for us, the axis we're talking about is the z-axis. So we're talking about an axis that goes through the center of our circle or through the center of our...
So if it's purely rotational, then I don't know if I understand why... why it's included in this equation. But I guess if we're solving one contact at a time, when we have two contacts, having them relative to each other, there are rotational forces that need applied so that stuff falls off of other stuff.
For box bodies. So we can scroll down here and get lots of different equations for the moments of inertia. And the first one we're looking for here is a thin solid disk of radius r and mass m. And you can see the z-axis goes right through the center of this circular disk. Okay, and that's exactly what we want. X or y about thin rectangular plate. Okay, and that's right here. And you can see about the z-axis. The equation is...
So I wonder about the citation in that, if that's helpful. No, it is not. Physics for scientists and engineers. Maybe this is cool though. I don't know. Oh wow, that's insane. This is like straight from... I wonder if this is... I mean, this actually could be useful. Torque. Tendency of force to rotate a body about the same axis is measured by the torque. Cool. So...
is right here, and we'll use that for our box bodies. All right, let's go back to our code. I'm going to go back to our flat bodies, and I want...
I think all he does is he basically just
going to make
implements these for the two types of bodies.
Okay, so I have some boxes and a circle, and let's see what I got. It has the inertia. Let's go ahead and result. So I'm going to pass out...
Position. Oh, this is interesting. Create box body 20 and 2. So I wonder what the scaling is in the world units for him, but that, yeah, 1280 by 768 is his screen. And then, yeah. Create box body. Right minus left. If I could see where that's defined, that would be really helpful. It seems like probably not, though. Left, right minus padding. Well, if the padding is... I guess that doesn't give us anything useful. Right minus left. Oh, it's the extent of the camera. I forgot you can do that in C#. So just 10% padding on each side. No, on... Wait. Padding times 2. I don't know. Basically, it's not... Doesn't seem... huge.
Initialize out.
Create 20.
See what it looks like. Oh, I think the color is actually body. So I'm gonna let's put one in here for this lead gray to work now. In fact, this one I think I want to move it down a little bit.
Okay.
Let's put it.
So that size was. Let's go back 20's writing it. 20, and it took up like half of the screen. Which is confusing because his extents... His screen is 1280 by 720, but the camera extents must only be like... something really small. So he probably is using some kind of logical units rather than pixel, which means maybe it's just a matter of tweaking these values to get something that actually makes sense. And I think maybe there's two problems here. There is also... Well, maybe it's the same problem, actually. Maybe the resting contacts on the rectangles are because of the inertia. So maybe I can try just hooking up like inertia and mass scaling. And then we can see how much that does. So for mass, what I originally did like 0.00, and then inertia was like 0.0001. Let's go back and look at that. So normalize into like, oh, you know what? I bet I can see. He checks at one point
add some color 25
in the debugger
on a little bit. That let's put it at
what the inertia values are.
Acting body per that.
Somewhere in here. Must have been earlier.
Let's try that. Objects in there. Let's we get the radius. Let's go ahead and scroll up. Need to do radius, and then we're calculating the inertia because we need to actually know what the shape. We have the radius is 0 because it's actually a box, but it does have a width and a height, so those look good. And then the inertia
his inertia is like 1.768. So
we're getting some good values there as well. Okay, so we have the inertia. Let's add.
I bet that's what it is then. I bet what I need to do is scale the mass and inertia to accurately represent the size of the objects, because right now they are ginormous. 100 pixels in a 1920 by 1080 simulation is not super big. But the simulation sees it as being ginormous, so why would it move out of the way of other objects? Which actually makes a lot of sense. So, what happens with this? What I would like to see... Yeah, I don't like... I think that's mostly just caused by the resting contact. The angular actually doesn't look that bad. What I really want to see is if I can coerce this into having these objects do almost exactly that, actually. That actually looks really good. There's no friction, so it makes sense why this wouldn't stop rotating. What happens here? I wonder how many substep. Oh, whoa. Okay. That's really weird. Try the same thing with a box. Well, yeah. It's not exactly right. Kind of weighing my options here. Circle 0.785398. Inertia is like basically 0. Okay. Rectangle. Basically the same, it's just heavier. Does have like nearly double the inertia, which makes sense why it would be doing what it's doing. What if I do like even just one more 0 on the inertia? Wow, okay. It transferred a lot of angular. Which actually is really good. Okay. That's honestly probably way too much angular transfer. Yeah. But maybe the friction solves that. Let's see. Maybe it's too much inertia. Or not enough, actually. It's probably more apt. Yeah, I mean, that actually looks pretty correct. So the rectangles are still doing the same thing. I wonder if I do like an initial, or an additional. Just give it like twice, just to see if they'll move around. Still doesn't really seem right to me. But I think it's probably because of whatever the problem is with the resting contacts. Yeah, so it doesn't bounce, it just sits there. Okay, the denominator is like absurdly higher now. Why? Because the inverse mass is 1. Why? Why is the inverse mass 1? Object mass greater than 0. What happens when we actually add it? Oh, did I like integer overflow by doing these like stupid values? It seems like I might have. The inverse inertia is like float max right now. Wait, that's for circles though? I think I did just overflow. What about that? No, it seems like I didn't. Maybe I should only be scaling the masses and the inertia values are correct. No, actually, well, I don't know. Let's see. It actually doesn't look like completely unreasonable. This is way too much angular though. That kind of nudged it nicely. What if I don't? What if I don't scale inertia? Well, actually, no, maybe that's right, because the masses in 2-bit are probably way lower. Because he's using the logical units. Will this bounce? Oh, it actually will. Okay. Well, that's actually a really good sign. Yeah. So the big problem now is... How do the resting contacts look? Does it do... It does the... I wonder if this will ever hit the floor. It does like a little hop every time there's 2 contacts, which I think is completely wrong. Possibly because when it does that, it's transferring the angular. Actually, it looks like it leveled out. Wow, that looked right too. What if I just put a bunch of stuff and just like watch? So the big thing is like that is falling wrong. And when it hits stuff like that, it should be transferring a lot more. It should be transferring a lot more energy into angular. Like it's very slow motion. I wonder what happens if I just make them heavier just to see. Because the gravity is super high right now. It seems like it will refuse to do any rotation. For the most part. Which is not correct. But I wonder if that's... Let's see what the impulse looks like. Is this 1 or 2 small contacts? I think it's... just one. So normal is like that. Mass of A is 100, which I think is pretty reasonable for an object this size. The inertia of A is like ridiculous. The inverse inertia is ridiculously low. RA, which is this. RB is this. And then there's no angular. The relative is 176. The contact velocity magnitude is 134. Which is the relative velocity dotted with the normal. Which the normal in this case is -x, +y. So I believe the normal in this case is coming from, it's here into here is the collision. So that makes sense for the contact velocity magnitude. RA perpendicular dot n, which is, this is RA, this is RA perp, dotted with the normal, which is this, probably gives like, I can't visualize that. It's like the magnitude of the, yeah, it's like a linear, visualizing the dot product. It's like a projection onto like the linear. So I mean, it's just giving us the impulse. Numerator 200. Denominator is really low, which is where we want it to be. We do want it to be like that 0.01. RA perpendicular dot n squared times inverse. No. What is that? Times IV? Inertia. Inverse inertia. Well, the inverse inertia is 0.000006, and the RA perpendicular dot n is -5. Squared is 25 times inverse velocity 0.25 times what is it, 0.50 6 0.00015. Yeah, that looks, yeah, that's almost exactly right. That's probably rounding. So the left of the denominator is the normal dotted with the inverse masses times the normal. So with the inverse mass, one is 0, the other is going to be really low. So that decays. And then the denominator right is that RA perpendicular squared. It also includes the RB, but the object's static, so it doesn't count. That all looks generally good. The numerator 201, I think I already looked at that. So it's giving us an impulse of like 20,000. Well, what is J described as? The impulse is J times N, so that it's like the actual directional force. I guess J is just like the linear, the magnitude of the impulse, and then the impulse is the magnitude times the normal. So it says applying impulse 0. Oh, why does it say? Oh, yes, that makes sense. Applying impulse 0 because that's a printout. So the linear velocity, I think these are correct. Lenvel delta is just the impulse. In this case, it's scaled with the inverse mass, which I think is right. It needs plugged into here, so J times N is, we already calculated the impulse as Jn. So actually, is that functionally equivalent? Yeah, it is. So we're fine to just multiply it by, by the inverse mass. I'm assuming my linear algebra library is not failing me. But I wrote it, so it's a possibility. Okay. So what do the angular velocity deltas look like? Ang Bill delta, and then Copilot do the same thing down here, and then run that, and let's look. Okay. Angville delta is RA crossed with the impulse times the inverse inertia, which is really low. Is that proper, actually? Yeah, it is. So this is what's screwing me up. So in this case, the inverse inertia is like basically as close to 0 as it can be. So how are we getting the J So, if all that's right, numerator, contact velocity, magnitude. Denom left is the normal dotted with the scaled masses. Denom right is these inverse inertias dotted with the perpendiculars squared. So I guess the perpendiculars are... I don't actually know exactly why. So we get like a ridiculous impulses J. 20,000 times like our inverse inertia 5 zeros 6 is 0.12, which is actually much further off. Well, actually, maybe it's not. $198.03. Times 1, 2, 3, 4. What's our inverse? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is actually let's include the fractional. 0.195312 is actually not the same at all. But that's not what we're doing, actually. We're doing the cross. So first thing, let's just have a look. Let's start calling inverse inertia. Wonder how much easier that makes it to read. It could be I've messed up the cross product. Okay, the bounce looked right. There's still no angular. The cross, what if we just like, what if I don't scale it? Well, that looks right, except the the bounce off the top there. Oh, that doesn't look right anymore. So it needs scaled by like something. It goes so fast, it just just disappears. So that's weird though. What if we scale by not the inverse inertia? We scale by like something manual. It's probably not going to look good with our different sizes of shapes. So, let's think. The impulse is really small. But the inverse inertia seems to work good for... No, that's actually still really wrong. Yeah, that's actually... So maybe the value needs tuned more? I mean, I can do the same mass scaling and just cut the inertia in half. Okay, well now it doesn't want to bounce. So what about mass a little lower? I mean, it's moving. I don't know. God, this is this is so frustrating. Can I just like get like a summary on in 2D game physics engines? How are mass inertia / logical sizes in the simulation typically represented, calculated, scaled? In specific, how do you marry inertia computation with your logical units? So it seems like it comes back to the density computation. Which I had set up eventually or earlier. What is inertia box 2D? Maybe I'll look at the in Discord. Aaron, the creator of box 2D, mentioned that there's some slides in here. So maybe I'll look at both of those in the box 2D source code, the light source code. That's actually something I was gonna do anyways. Okay. Let's see. Moment of inertia is the sum of the masses times r squared. What is r squared? Can we get some explanation? R is the distance to the axis of rotation. So, but if the center of mass... Distance to the axis of rotation. I see. So you have to think about it in 3 dimensions. So in 2 dimensions, this R must be... If we're rotating on the Z, which is... how'd you say? It goes through the 2D plane. That means the distance is the extent. So for a circle, it's the radius. And for a rectangle, for a rectangle, width plus height. I don't know if I fully understand that. Two masses can be approximated as point masses. Okay. So twice as hard to rotate the barbell about the end than it is about its center. Yeah, I mean, that makes sense. Infinitesimally small piece of mass. So this seems like... Right. Recognize that 1/12. Cylinder R. Center mass plus okay. This is not ridiculously helpful for my purposes. I think the problem I'm struggling with is the normalization. Let's look at the box 2D slides. This is all pretty standard. Always using Euler's. Euler? Well, this actually looks pretty... This looks pretty similar to the Hecker, right? Because the linear is the impulse magnitude times the inverse mass. So this is the delta. I'm assuming this is delta time inverse mass force, which is basically the same as the impulse magnitude. As far as I understand, the force is just the instantaneous impulse, I guess. I'm mangling terms, but and rotational is the same with inertia. Inverse inertia times the torque, which I guess we're getting here. Is it dotted with or times? Times torque. So maybe there's something funny going on. Maybe it is different. I don't know. As far as the angular. Impulses are applied at each contact point. Okay, we do the same thing. Computing the impulse. Normal impulse causes an instant change of velocity. We know the direction of the normal impulse. We only need its magnitude. This is true. Relative velocity along normal. Yeah. He's including the... Yeah. Including the angular velocity. Times R2. So he's not using the perpendicular. So it seems like it diverges in the end of the solver, but it's basically the same thing. As this is R1, this is R2. They point from the center mass to the contact. And then so this relative, is this like the magnitude of R2? Or is this actually relative given as a vector, I think, maybe. So it's literally apply each of these to R2. I don't know exactly why you would want to do that, but normal impulse. This looks, this KN looks strikingly similar to the denominator in the Hecker article. You have the inverse masses. It's not dotted with the normal. Yeah, so both inverse inertias with N dotted with R, but it's not squared. So I'm not sure why these are different. Actually, probably because that squared is manifesting itself in our... No, I don't know. I don't know then. Bias velocity, friction impulse. So I haven't even gotten here. I wish I was on the friction stuff, but let's go all the way down. But I don't know if it'll let me load this. Oh yeah, this is way longer than apparently GitHub can handle. Okay. Where was I? On bias stuff, right? Yeah. So it's bias, friction, sequential at each contact point. Do it for several iterations. Naive. Each is independent. Each contact point forgets its impulse history. So I wonder if this solves... I wonder what this does for my problem with the resting contact when we come in and out of rotation. But I already do sub-stepping, it's just not aware of before.
These are probably just going to start talking about numeric stability, maybe. Okay. Joints, I wish I was doing that. Yeah, I think this is... Well... Arbiter exists for touching pairs, basically the same as a manifold. Provides coherence. Matches new and old contact points. Accumulates impulses. Joints. Ground is represented with bodies whose inverse mass is 0. Yep, I do the same thing. So, what I wanted to get out of that is the impulse. I keep mixing up impulse and inertia. What I wanted to get out of that is an explanation of the inertia scaling. But no dice. So maybe this one will have some more luck. Or I can read up on game physics. Let's look at these after. This Box 2D logo hasn't changed since 06. Okay. This is more or less the same thing. So inertia tensor. I wish this was recorded. I guess I could look at the inertia tensor in Box 2D Lite right after this. Or right now at the same time. So I would imagine it's probably so you actually refer to it as I. That would be really annoying. Body. Oh my god, actually she does. Okay. So let's search for inverse I. So we said it. It should be super high if it's immovable. And the inverse should be super low if it's immovable. So from what I can tell, the inertia calculation is the same. Just dividing by 12. 1/12 times the width squared plus the height squared times the mass. Excuse me. I don't care about joints right now. So the arbiter is doing some weird stuff with the normal. I don't know why it's touching the inverse inertia for the normal. Angular is the inverse inertia times the torque. So can we make sense of that from the... Make sense of that from the slides. Getting the impulse. No, I don't know. This is not useful. Not useful. Not useful. Not useful. Not useful. Not useful. So this is... Oh, don't care about joint. So this is apparently it. I don't know what to make this. So it seems to be super simple. Maybe I will look at how can I like just go back to what I'm on? Okay. Maybe if I look in how the samples run. We can look at how it's set up. I think another thing that's maybe important is I have a ridiculous gravity setting right now, I'm pretty sure. It's not as ridiculous as I remember, actually. Okay, so he actually inverts, the coordinate system, it looks like. Well, it's the correct -y descending. Which is opposite of mine. Draw body, draw joint, launch bomb. Demo 1. World add B. So Vec 2. I don't like how non-descriptive C++ is. Okay, I have to chase through these initializers. So everything is implicitly calculated, I guess, in this set. Or the set is... No, this is in body. So... Body set. The width... So he's discarding the height? No, the... Okay, that's really non-standard. The width is a vec2 that contains the height. That's really weird. My eyes. So this is pretty large. It looks like he's using pixel coordinates. The second option in the set is M, which is the mass. So he's not doing density, he's doing mass. And for this, he's using a mass. Mass of 100, so fairly large. Setting some friction. I mean, none of this is that different. The coordinate system is like the same too. which is kind of more confusing. Maybe it's not. No. Actually, maybe it is logical. 120, 120. I think that's like a floor. It takes up the whole thing. Let's compile this and look. Wish I could figure out how to get my pace to stop doing that. Wish I could also figure out how to type. I think it's just build sh. Jesus. Okay. Samples. Okay. Demo, I was looking at demo 3. Demo 3. So, I mean, these are, like, huge. This is probably, like... Is it 1280 by 720? It's maybe. Yeah, it is. So, maybe it isn't, the exact positional. 0.5 times body width. Wait, what? Why would you do that? I don't understand. Maybe it's like being stored as who there is a unit conversion, but the body position, no, the body position is used straight up. So plus R. And these are just the vertices. Oh, maybe because it's the center? Yeah, that's why. Okay, so that makes sense. But it still seems like... Demo 3. Yeah, none of these are very big at all. But physically, they take up a lot of the screen. This is pretty fun. I wish I could mess around with mine like this. Okay. So maybe that means I need to mess around with more coefficients, but I don't know. Let's ignore for now. Narrow, I know. I wonder if I should clip. I don't know if that's a problem for me right now. Gravity time plus inverse mass times force. Relative velocity. Effective mass. Effective mass versus box width. Wait. How is that? Because mass is M. So it's looking potentially collide or arbiter does the effective. Probably arbiter? I would have thought it would be in body. It doesn't really seem to... kind of burning out. Okay. Well, I feel like I've done nothing this whole time, which is what I felt like for the past, like, week. Every time I try and debug this. God, it makes no sense. Publications. Oh god, this is gonna put me in a rabbit hole. These are cool. Wow, he's spoken at GDC a lot. Game programming gems? That's cool. I don't know if I'm gonna see anything cool in here. I bet Wikipedia doesn't have anything interesting. Yeah. I have this book. Yeah, I guess that's something I can do is look through that book again, but that's not for 3D, or not for 2D. So... God. Well, I kind of did everything I said I would today. Check Hecker equations, check inertia, look at box 2D light. I don't think any of that gave me, like, any actual genuine insights. I wonder if maybe clipping is my... Well, that's moving kind of interestingly. Yeah, it seems like almost like everything is fine. It just needs like the values tuned up. It's probably like one of those things that's gonna be just like painfully obvious once I figure it out. Which makes me think maybe it's the values tuned, but it's very much like, well, actually, doesn't look like it's spam increasing velocity because the impulse is wrong anymore. In the past, stacking boxes were doing very crazy accelerations. I would like to see that bounce there. I'm not sure why it didn't. Probably maybe because it didn't register as both contacts. It registered as one. Okay. That's kind of fair. I don't know. What if I like
What if I don't scale anything? What is this song a remix of? I swear I swear that's from Everything Everywhere All at Once. It looks right. There's just no there's just no angular. But I really don't like the way that responds. Maybe that's an issue with the density. Actually, that kind of looks like what you would expect. Like, that's why it's throwing me off. Like, when something's moving like that and it has a lot of inertia, you'd kind of expect it. If these throw themselves off, yeah, that's potentially fucked up. Well, not potentially, it definitely is. I just don't understand. I don't understand how it's fucked up. This is like the most annoying. This is so annoying. I wonder if I just need to start from scratch again and re-implement the whole thing to figure it out. I have no idea. Well, I had something else I was thinking about, but I almost can't remember. If I could just have this, I would be so happy. It's not very complicated either. Yeah, with the joints would be awesome. I don't know. It seems like I'm back at square one if I undo the scales. So what did I have earlier that gave me like really good results? Like just scale the inertia and the mass by like a lot is what I did. But then it increases on each collision, and they never sit flat. And that impulse should have gone, part of that should have gone vertical. How many sub steps am I doing? Oh, only one. What if I do like 100? Well, let's start with 10. Well, comes to rest a little bit easier there. It's not dispelling its angular velocity. Actually, it's growing the whole time, which is not what we would want. What about literally 100 sub steps? Does that make it small enough to where It doesn't do that. Well, it looks like the answer is actually yes. Yeah, I really don't like the way that that falls off the side. It just doesn't look right to me. That is also definitely not right. This is also not right. But maybe... Is that like a behavior implementation thing, or is that like coefficients thing? That is not right. For sure. I don't know. Ooh. Did I even change a single thing today? No, I haven't. I have nothing. I have nothing to show, literally. Oh my god. Okay. Ah, fuck. I think... What do I think? I have to think. Could do Willer. Yeah, Euler.
Euler.
This doesn't really make sense. I've heard things about Verlet too. So, the other thing I was gonna check, let's see if I'm applying this correctly. So I didn't totally understand the cross
Took this cross from 2-bit.
Contact points, which is in a pre. We have this until I've
So still divided by contact count.
calculated the impulses for both angular velocity and this part does not change the positive impulse. And basically what this means is that times the inverse inertia, because this is rotational acceleration. And you can see it's not actually going to work this way because this impulse is a two-dimensional linear.
So
value,
it must.
and we need to convert
okay,
it.
Hold on. If we don't apply this at all, then it's still, the values of the inertia could matter less because they're still affecting the impulse, which is being calculated correctly. Or maybe I'm wrong, because this doesn't look right for rectangles. I don't know why. They're heavy, I guess. I don't know. Their inertia's too much. And this is very incorrect. It's not pushing up enough. Did I do something weird? Oh, I still have this. So if I set this to 1, if I set these to 1 and the non-angular is fine, then there's hope. Yeah, I mean, that looks relatively reasonable to me. They do get a lot of inertia, and kind of refuse to bounce off other stuff, but that kind of makes sense. If other stuff is stationary, it shouldn't affect it that much. So like if I do this, it should like eventually almost stop, right? No, never. Doesn't seem like it. And the stacking is not working properly at all. Yeah, no, it's like, it's all joining. There's no, that is very screwed up. Okay, well, maybe all hope is lost. Just doesn't make much sense. I mean, this is like legitimately this is the equation. Like, this is the exact same. The only thing that changes is the values. Let's change just the mass. If I can get like non-screwed up stack. Yeah, that's just not just not right at all. It should not be happening. Because the inertia needs scaled identically. I don't. At this point, I'm just looking for any connection I could possibly find. Yeah, I have no idea. It does not work at all.
to a radian value. So the amount of
Even
kinda
just the angular is wrong. Like, it's such a shame because I really, really don't want to have to rewrite these contact generation equations because they were a huge pain in the ass. That was almost a month ago. But maybe it's better than me sitting here for another month just staring at it. God. Also, I have like broad phase, spatial grid stuff. Oh, the inertia is killing me. What about I don't know. I should throw in the towel. What can I even say about what happened? I think I need to start. The next step is to start over. Which kind of really, really sucks. But basically create a smaller sandboxed version. And re-implement with but I don't understand. This is the basic resolution, which is the exact same, but it just uses the inverse masses. I mean, this seems good to me. Even this took a while. So the basic resolution, we're doing the same thing. This is this. Inverse mass plus inverse mass. Huh, but it's not dotted with the normal. Wait. Why is that? I don't know. I give up for now. This is dominating too much of my time. Well, I'll do I guess like a summary. What was that? Auto. Interesting. Just Copilot wanted me to say suicidal for a second. What day is it? 122. Okay. Hecker equations seem right. Basic resolution differs.
Inertia formulas. I messed with scaling coefficients, but couldn't find good value, working value. For this, it was like no scale equals not enough inertia. Wait. No scale is too much inertia to... I don't know. I honestly can't remember. I should have been writing this down as I went along. I don't even know. I'll just leave that as it is. Box 2D light. Seems like they're using logical units. I don't know. That was still weird, the box 2D stuff. Basically, conclusion. Yeah, I mean, that's pretty accurate. I have no idea what the problem is. Conclusion. What the fuck? Conclusion. Start over. Begin with inertia. And fill in the rest later. The broad phase. Oh, I just launched my mouse. Yeah. I am just gonna push this so I have my thoughts in order. Debugging progress in air quotes. Cool. So I figured out basically nothing. Actually, not basically. I figured out nothing. I think I'm just gonna restart, maybe. I don't know. I don't know what else to do. It seems like the foundation I built on is like I patched in these values after the fact. So maybe intuitively there's some problem with could be the densities. 0.1. These are relatively low density objects. But that's for the mass. Am I respecting the density? I am. So what happens if I have more dense objects? Well, that looks a lot better. Actually. How many did I change that for both? I did. Well, so this is what, 10 times denser. So when it's colliding with these other dense objects, it actually matters. Oh wait, am I still on the basic resolution? I am. Alright, well, let's see it not work at all on the rotational. Yeah. Boom. Okay. Well, this has driven me insane. I think I'm just gonna call it for now. I don't know what else to do. I think I've talked to myself for 2 hours and 10 minutes. I think that's good enough.